Okay, boys and girls. Okay, we are going to start our lesson. Take out your lesson number 9. Lesson number 9. Okay, boys and girls, lesson number 9, we're talking about impulsive force. What is impulsive force? Actually, it's force. Previously, we learned about force, right? We learned about F equals to ma. We're talking about the force, we say F equals to ma. Actually, also related with this, okay, impulsive force actually is one type of force, which is a very large force that we producing or we acting over a very short period. Okay, for example, in the accident, in a very short time, we create a force when collide with another object. One object collide with another object, so they were producing a very big force, which is called impulsive force. The force that produced in a very short time, we call it as impulsive force. Basically, you can just call it as force. That's all, force. Okay. So impulsive force formula definition. Second sentence actually is the definition. Okay, so I give you the formula first. F equals to mv minus mu over t. Okay, still remember what is the mv minus mu last week that we learned? Mass times velocity actually is the momentum. Still remember, this is what we learned last week. Okay, mv minus mu actually is change of momentum. Okay, per unit time. Any of you can tell me how to define per unit time in physics? We got one word. Okay, we got one word. What of change of momentum? Any of you know how to define impulsive force? If you know, can you type in the chat box? Recall how we define acceleration. Acceleration is v minus u over t. How we define this? What of change of velocity? What is this? To represent per unit time. Okay, per unit time in physics, we call it as rate, R-A-T-E, rate of change of velocity. This is how we define acceleration. Okay, how we define impulsive force actually is the same thing. Okay, change of momentum. So per unit time, we will say that rate of change of momentum. Okay, you have to know what is the symbol represent. M represent your mass. V represent your final velocity. U is initial velocity. And T is represent your time. Okay, do you know what is the SI unit for impulsive force? Any of you can type your answer in the chat box to me. What is the unit for impulsive force? No? It's just no? I ask you another one question. What is the unit for force? What is the unit for force? So what is the unit for impulsive force? Yes, correct, Newton. Okay, Newton is the unit for force. Impulsive force also force. It's one type of force. Okay, so it's Newton, N. Okay, why just now I said that the previously Newton's second law we say F equals to ma, right? Actually, it's same thing like what we learned right now. Okay, can you see that my A is just now I got mentioned at here. A is what? A is V minus U over T. If I replace this A into this, can you see that? mv minus mu over t. mv minus mu over t. I just put this v minus u over t inside the a. So actually I get this. So impulsive force actually is still the force. If you forget how you count the impulsive force, never mind. You're using F equals to ma to do calculation, you're still able to get the answer. Okay, because they are the same. Okay, from the impulsive force here, we need to learn another physical quantity in physics that we call it as impulse. Okay, what is impulse? We write it here, formula. F. Now I move my T here to another side, so it becomes F times T. Okay, so Ft equals to mv minus mu. Okay, so for impulse, how we do calculation and find impulse, actually we got two formula. For impulse, one of the formula is the force times time. Okay, product meaning times. Product meaning times. Okay, product of force, or we say impulsive force, that doesn't matter. Impulsive force and the time of impact. Force times time. This is called impulse. Or second formula, we can using mv minus mu to do calculation to find the impulse. So impulse, we can say it is mv minus mu. Just now I got told you, this is called change of momentum. Or we say change in momentum. So at here, I want to emphasize impulse, we will have two formula. One is Ft, another one is mv minus mu. Basically, both will giving you the same answer. It just depends on what information provided in the question. Okay? So right now, again, can you try, based on the formula force times time, can you tell me what is the unit we can give to impulse? Let's just try. What is the unit we can given to the impulse? How about others? Hui-Tong, Megan, Crystal? What is the unit we can give to impulse? For unit, actually, we can just derive it from formula. Any of you? It's not that hard. Try force times time. Force times time. What is the unit for force? What is the unit for time? That is the unit for impulse. What is the unit for force? What is the unit for time? Yes, correct, Licious. N times S. Force in Newton times in second. So another, because we say that it's not only Ft can calculate impulse, mv minus mu also can count impulse. Can you give me, if mv minus mu, what is the unit we can use? What is the unit for kg? Yes, very good. Correct. Kg meter per second. So in study physics, we are studying smart, okay? No, don't trying to memorize. You memorize, you will kill a lot of brain cell. But from the formula, we can know the unit. Okay, so SI unit, we can write NS or we can write kg meter per second. Very good. Done? If okay, then I'm going to page number 2. Can you give me some reaction? Yes, Hui-Tong, okay. How about others? Megan, Crystal, Licious? Crystal, okay. Megan? Megan, okay. Licious, okay? Okay, like boys and girls here. Page number 2, I make a smart summary for you. Impulsive force. Force. So F. What is impulsive force? It's force. Force is, you can write MA or MV minus MU over T. Impulse is, we move the T to another side, so it can have two formula. Okay, impulse can have two formula. One is F times T, or second one can be MV minus MU. From the formula, we can define. They might be asking you, what is impulsive force? So for the first one, impulsive force is rate of change of momentum. Okay, so this one, change of momentum actually is mv minus mu. Rate meaning that per unit time. Okay. Okay, before I forget, I need to tell you that actually our lesson is 1 month 4 lesson. So today is the 4th lesson for this month. So next week, Thursday, we will rest for 1 week. Okay, because October we got 5 weeks of Thursday. So now, right now, actually, we already complete. Today we'll complete 4 lessons per month. So next week, Thursday, actually, we don't have lesson. Okay, everybody relax for next week. Okay, for impulse here, you can define based on this F times T product of force and the time, or we can define based on mv minus mu. Okay, I like to using change of momentum to define, because later on when we do more partial question, we will find that when they're asking you impulse, they expect you to find using mv minus mu. So I using this as my definition. Okay, so here SI unit for force is Newton. SI unit for the impulse is NS or kg meter per second. Okay, can you guys tell me? This is a scalar or vector quantity? Correct, correct, dear. Vector quantity, because it has magnitude and direction. Okay, so at here force. Force is a vector. Involved with force, of course, we need to be consider the direction. So for impulsive force or impulse, they are both vector quantity. Okay, here is some example that we applying impulsive force in our life. Sometimes we want our impulsive force to be high. Sometimes we want our impulsive force to be low. Okay, depends on your application. For example, this one, high jumper. Okay, you want to reduce when you jump and then you fall down. Why we need to have a mattress, thick mattress at here? Actually, you ask yourself, you want high impulsive force acting on you, or you want a small impulsive force acting on you? Okay, obviously we don't want the force. The force acting on us, we will get injured. So we want to reduce the impulsive force. But how we reducing the impulsive force? F equals to mv minus mu over t. Okay, at here, how you are going to reducing the impulsive force? Actually, you can trying to think how you increasing your time. Imagine a value divided by a very large value. The force will become very small. 1 divided by 1000 is 0.001, right? Okay, so the time is greater, longer time. Actually, the force will be reducing. Okay, do you know that nowadays our car design, actually the front part is crumble zone. Okay, the front part is crumble zone, so that when anything happen, actually the front part of the crumble zone, it will be lengthen the time for the car to stop. So actually, this is the front part of the car. Okay, so anything happen, accident happen, so this part actually will be like Milo tin, okay, crash, and then it lengthen the time to stop. Although your car will be seriously damaged, but actually this action is because we want to protect the passenger. Okay, we lengthen the time. Okay, so we are reducing the impulsive force acting on us. Okay, we lengthen the time to reducing the impulsive force acting on us. So at here, this one also the same. The mattress. Okay, the mattress actually can be compressed and then stop you. Okay, so when you fall down, it will compress and then stop you. So can you see that the time actually is longer? The longer the time, actually, the smaller the impulsive force. So this is one to this application is one to protect us. Okay. So next, what else we are going to reducing the impulsive force? Long jumper. Okay, you see that here we preparing a loose sand. Okay, why not concrete? Okay, why not just normal land? Okay, so cannot, because we want to protect your leg. Okay, protect. How to protect? Loose sand actually can longer the time. It make you a longer time to stop you. Okay, so at here, same reason. These two cases are the same reason. We want to increase the time to reducing the force acting on you. Okay, Then how and when we want to increase the impulsive force? Okay, we can look at this case. Okay, if you are helping your mothers, okay, in cooking, okay, so you will know about these two, pestle and mortar. What is the surface of these two? The surface actually is very hard material. It's making of hard material, hard surface, rigid surface. So when you going down, using a pestle going down and hit the mortar, the time of impact is very short. Okay, so at here, impulsive force mv minus mu over t. The time for them to contact actually is very short time. Imagine 1 over 1, 100 over 1. You get 100 is a big value. Okay, big value. So if your value for time is small, your impulsive force actually will become high. Okay? So if your mathematics not good, I just simply give an example. 100 divided by 100, you get 1. This one, 100, you divided by a small value, let's say 1. So you get 100. Can you see that your force actually increases? This one, your force actually decreases. If what I told you, you cannot catch the idea, then we can try to put some value and see their relationship. So just now the case is same mv minus mu, but I make the time become longer, 100. So it only become 1 Newton acting on you. Example, okay? Now, pestle and mortar, actually they are hard surface. When they are hard surface, the time for them to impact, contact, and then stop, actually the time is very short. So I make it like only put 1 for the time. So you found that your force is actually 100 Newton. Actually, it's higher force. Okay, so we want a larger force. Actually, we want to cause the spikes to be crushed easily. Okay, so here, how about this one? Hammer. Hammer also the same one, right? Hammer, okay, we knock on a piece of metal. So material actually also hard material. So hard material, so when the impact of time will become short, causing a larger impulsive force. Okay, so this is the idea we're using physics concept and apply in our life. You ask yourself, you want a big impulsive force or you want a small? If you want a small impulsive force, then you have to think how you make the design. Okay, how you make the design so that it won't be experience a big force. For example, the egg. If you want to drop from a high building, of course, we just drop like that, the egg will be cracked. Okay, so we have to think how, using foam, using whatever newspaper, using whatever the things to cover on it, and then only drop it. So why? Okay, all the foam, all the what polystyrene or whatever, actually they're helping us to increase the time, of impact. So after that, we can reducing the force acting on the egg, something like that. Okay, so this is the idea and applying physics concept in our life. So we go to your page number 3. Okay, until here, okay or not? Give me response, then we can go to page number 3. Megan, okay, Okay, Hui-Tong, Crystal, Teresa, Licious, okay? Okay, they're here. This is the one. Okay, although we didn't learn physics, but we automatically know how to save our life. If let's say you are jumping from a certain height, jump down from a wall, he lands on the cement ground at a velocity of 6. Okay, initially 6 meter per second. What is the difference between these two? One is bend your leg, bend your knees. Another one did not bend. So which one you imagine if you are jumping, then which one you are going to use? Actually, our body know how to protect us. Okay, then I want you help me to calculate what is your impulsive force will experienced by you if your initial velocity is 6, at the end we stop at 0 meter per second, the time that we use is 1 second. How big the force experienced by your legs? Can you count for me? And then also count for this one. If you didn't bend, the time of impact is 0.05. What is the force that you were experience? Okay, so boys and girls, I want you to do calculation right now. Take out your calculator. Teresa, you just joined us. Just now I got tell Emily also. Just now I got tell them that our 1 month actually we got 4 lessons. So today is actually our fourth lesson already. So next week actually we will rest for 1 week because for October we got 5 weeks of Thursday. So today actually is the fourth lesson for this month. So next week actually we don't have lesson. Okay, let me have a look. What is your answer for the bending and didn't bend? What is the difference? Same person, but just the way how you landing is different. So can you tell me what is the first experience by the first position, first posture, and second one? Any of you, dear? It's not that hard. What? The mass is 50 kg. You have to try to give me the answer so that I know that you understand and you're able to solve it. If you wait for me at the end, you just copying my answer, I worry you haven't learned anything. 会痛. Correct. 会痛, correct. Okay, so boys and girls, did you able to get the same answer as us? This is negative 300 Newton. Negative actually is just showing direction, opposite to your initial motion. You falling down, okay, jump down. So the force acting on you is in this direction. That's why you get a negative. Okay, if you didn't get a negative, also correct. Okay, the main thing is we want 300. Okay, yes, Megan and Emily are correct. If your final answer for this is 300 Newton, also okay. Positive, negative is just showing you direction. Okay, your initial motion is going down, you jumping. So at the end, if you get a negative, meanings that the force is acting oppose your initial motion. That's all. Okay, it's just represent direction only. Okay, so this one, 300 Newton. Second one, F equals to 50 times 0 minus 50 times 6 divided by the time is 0.05. Shorter time. At the end, your answer should be negative 6,000 Newton. Can you see that? One is only 300 acting on your leg. Another one is 6,000. So the second one, actually, you will get injured, you know. You will get injured. So don't play. Okay? So for this, but luckily lah, even though we didn't learn about physics, our body know how to protect ourselves. So it's fine. Okay, the shorter the time. So can you see that? My time is 0.05. My time is short. My impulsive force become very big. This is what I told you just now from the formula. F equals to mv minus mu over t. When your time becomes short, your impulsive force will become very big. Okay, so at here, larger the impulsive force. If time is longer, smaller the impulsive force. Higher short, yes, correct. Teresa, correct. Smaller. Impulsive force is a force, so we say smaller force, correct. Okay, done? Then we can try past year question. After we learn about impulsive force, impulse, then we are going to try with our past year question. Is it okay? Give me some reaction, then we know that we can proceed. Okay, we talk. Okay, Megan. Okay, Crystal. Okay, yes, good job. My dear, here. This is 2020. It's a MCO past year question. Okay, keep a stationary. Okay, so boys and girls, this is one of the keyword. Starting the football is at stationary. After that, the foot in contact with the ball, time of contact, or we say time of impact, this is time. The mass of the ball is 0.4, right, M? Speed of the projection. Initially, object is football is stationary. So initial velocity, you put U. This one, finally, you put V. What is the force? Although they didn't mention about impulsive force or force, that's all. You're using the formula of force. What is the force? Can you do calculation? I do it. You want to using F equals to MA to solve? No problem. If you want to using what formula that we learned today, F equals to MV minus MU over T, also no problem. The most important is F equals to MA. The A at here they didn't provide, but you have to find it out by yourself using V minus U over T. Okay, do it right now and then tell me your answer. Megan, correct. Megan, good job. How about others? Megan, you can try question number 2. So we read the question, we try to find information. Just now stationary, so I know initially is U equals to 0. Emery, correct. Okay, so F equals to MV minus MU over T. Mass is 0.4. V is final 25 minus 0.40 divided by 0.05. So your answer is 200 Newton. Answer should be C. Good job. Hui Tong, correct. Okay, so those already okay. You try with question number 2 without giving you any hints. Can you try to find out what is the period of time? Hui Tong, no. Try again. Yeah, correct. My bad. Hui Tong, correct. Hui Tong, you can try question number 3. How about others? Question number 2. You guys have to type your answer to me so I know that you already solved the question, no matter it's correct answer or not correct, incorrect question answer. Please tell me your answer. If you didn't respond to me, I will assume that you are actually still trying. So I will wait for you. If I wait for you, but actually you already finished, then we are wasting the time. So please let me know. Carissa, good job. Yes, correct. F equals to MV minus MU over T. For M is 1.2, final is 5, minus 1.2, initial is 2, divided by time. So you finding mathematical move here and there, you'll get the answer 0.9. You see, they will put 0.90 because two significant figure. If right now we are answering paper 4, okay, you need to give me 2 to 3 significant figure for your final answer. Some of the students, they might be asking me, teacher, why you know that is using impulsive force? Why not impulse? Actually, my answer is impulse also can get the answer. Because these two formula actually they are the same, just they move in a different position only. This one is called impulse. So the 4 times 2, 4 times the time, then 1.2 times 5 minus 1.2 times 2. Can you see that actually it's exactly the same thing? It's the same thing, no matter you're using impulse or force to settle it. Because in this both formula, they're having the same physical quantity involved in the question. Okay. Try with question number 3. Here, the hints that I want to remind you is force is a vector quantity. So direction have to consider. Cannot ignore the direction. So when they're going down and going up, so basically one of the velocity, you have to make some changes. Like the momentum last week that we learned. Move in opposite direction, then what's going on? Have to consider direction, dear, because force is a vector quantity. Oh, Emily, let me have a look. No, Emily, be careful with the direction. I give you guys one more hint. Going down initially, I can put positive. If they rebound, keyword rebound, that means opposite direction. I have to put a negative for the direction. I think, Emily, you didn't put a negative. Try again. Huy Thông, no. No, did you put a negative? Let me check Megan. Megan correct. Megan correct. How about Teresa? (0.5) final is minus 8. Minus 0.5 initial is 10. Divided by the time 0.50. Okay, so here I want to emphasize for this question is the rebound. So it's already opposite direction. We have to put a negative. Opposite direction. So my answer at here, I will get a negative 18 Newton. So C or D. Which one is my answer? As I told you just now, negative is showing direction. It's opposite to initial motion. So you see, going down, I put as positive. Going down, I put positive, so negative, it will be upwards. Opposite to it. So answer will be C. Is that clear, dear? Yes or no? Yes or no? Is it okay? Megan, okay? Teresa? Huy Thông, okay? Okay, then we proceed to the next page number 5. Okay, Licious, okay? Okay, number 5, page number 5. Here, question asking you to find impulse. Okay, impulse. So can you try? Same, impulse also a vector quantity. Impulse got 2 formula. You have to decide from the question which formula we are going to use. If you get the answer, you let me know. Only of you should not be hard. You're able to answer. Just be careful with the direction only. This is the thing that I want to mention. Teresa, no, Teresa, have you remember? Oh, are you adding up the speed? No. Teresa, you try using MV minus MU. Y10. Y10, what is the unit? What is the unit for impulse? But there is no time. No problem. Because impulse, we got two formula. Teresa, impulse, we got two formula. One is either using FT or another one using MV minus MU. Oh, I know, because Teresa, just now you came in late. You are joining us somewhere here. Just now we got learned two. One is called impulsive force. One is called impulse. Impulse, we got two formula, FT or MV minus MU. So you based on this formula, based on this question, which one is suitable for you? We can using MV minus MU. Okay, try again. Crystal, I want to ask a question about 3. Y is 0.5 minus 8. Let me have a look. 0.5 minus 8. This is before collision. So this is initial. U equals to 10 meter per second. Okay, Crystal, this is before collision. So this is initial velocity. After collision, that means this is your final velocity at meter per second. But can you see that? This one, just now the ball moving downward. Now it rebound. Rebound, that means opposite direction. So we have to put a negative value. We have to put a negative value. So at here, MV, mass is 0.5 times negative 8 minus 0.5 times initial velocity, which is 10. Like Y is negative 8 is at the front. Oh, okay. You understand after collision. Okay, let me check others. Answer, Megan. Megan, question 4 No leh. Megan, no. Emily, you come back again. Yes, Emily, correct. Okay, boys and girls, we were using impulse using MV minus MU. Because at here, I don't have force, I don't have time. So I cannot using the first equation. We're using the second one, change of momentum. Mass is 2, final velocity. This is called initial. This is called final V. You see, they are opposite direction already. Okay, opposite direction. So we need to put either one as a negative. You can put either one, okay? For example, I can assume to the right is positive, to the left is negative. So if I assume in this way, so I put a negative at here. Final velocity is 1. So I put 1 minus 2 times negative 3. Negative is because opposite direction, okay? This one is moved to the right. Here is initial is moving to the left, opposite direction. So our answer will be A. But then just now, who is that? Is it Megan or who? Not Megan. Hui Tong. The answer, I don't know who is it. Hui Tong. Okay, the unit is wrong is because this is called impulse, dear. Impulse, okay, MV minus MU is kg meter per second. But there is another unit called F times T, which is N times S. This one unit is kg meter per second. Both are the same. So, or 8 Newton second. So our answer should be donkey. If Newton, this is force. Impulse is change of momentum. Impulse and force is different. Force have to divide by time, but impulse no. Is it okay? Okay, so Crystal, this one, the ball is starting at here. So ball is moving to this direction. So I put this as U. Then hit and rebound. Rebound normally is meaning that it's hit and then rebound. So it's opposite direction. So this is final. Crystal, for this question, okay? You get the idea why 1 is V, -3 is U. Is it okay? Okay. So boys and girls, I want you to try question number 5. Impulse. What is the impulse? Do it by yourself. You might get a negative value, doesn't matter. The most important is the magnitude. The negative is actually represent direction only. I take attendance first. Teresa, correct. Teresa, correct. Hui Tong, correct. Okay, so at here impulse Ft equals to mv minus mu. Which one we want to use? We use the second one. First one, we don't have the force, we don't have the time. 0.25. So hit the wall, this is initial. Rebound, highlight rebound. If rebound, that means opposite direction. Your V here, put a negative for it. Put a negative for it. So you will get -12 minus 0.25 times initial 16. So my answer will get -7 Newton second. Negative is just showing direction, doesn't matter. Okay, doesn't matter. Okay. We can assume that your ball is here like this. Okay, it's moving to this direction. So we put U equals to 16 meter per second. Hit and rebound. Rebound here become V equals to -12 meter per second. Then we'll get this answer. We can also assume in another way. I can assume that this is my wall. Then my ball is moving in this direction, which is U equals to 16 meter per second. Hit and rebound. Rebound is 12 meter per second. So to the left, I put negative. To the right, I put positive. So if I put in this way, mv minus mu equals to the 0.25 times 12 minus 0.25 times -16. If like this, I will get a positive value. So that's why I want to tell you that no matter positive or negative doesn't matter. It's just showing you direction only. Okay, it's just showing you direction only. Initial, my direction is to the right. So right now negative meaning that impulse is acting opposite. That's all. So initial, I assume to the left is negative. Now I get positive, that means opposed to your initial. That's all only. So doesn't matter with the positive or negative. It's just showing direction. So our answer should be 7.0. Okay, again. 0.0 is because two significant figure. If this is a paper 4, so make it two significant figure. Any question? No question. We are going to the next question. Page number 6. Is it okay? Okay, Crystal, okay. Hui Tong, okay. Megan, okay. Teresa should be okay because just now she answered this correctly. Okay. So boys and girls, this is a train. Total mass for the train and passenger is 750,000 kg. The train is traveling with a speed. Oh, this is the initial speed. So label U. Okay. Then apply the brake. The train will take 80 seconds. So this is the time. Second is time. Okay. To slow down to speed of this. This is your V. Final. This is your mass. Can you calculate the impulse that make it slow down? Okay, count it. Make it two to three significant figure lah. No, Teresa, no. They are moving in the same direction. Try to check again any value that you make mistake. Any others? How about others? Impulse. Final is 42 minus initial. Megan correct, but I also not correct leh. Why ah? It's my problem. Did your working step same as me or not, dear? My answer is negative 31500,000 kg meter per second. Can you help me to check? Is it my problem or your problem? Is it working step same as me? Hui Tong says same as me. So should be you guys didn't press your calculator correctly. Check again. Okay, it can be kg meter per second or ns. Okay, so 3 mark, dear. 3 mark, please. Formula 1 mark. Substitution 1 mark. Final answer with unit 1 mark. Okay, do not skip any step. Don't need to divide 80. No need, because this is impulse, dear. Krista, impulse we got two formula. One is F times T. Or you can using MV minus MU. That's all. No need to divide it by time. If you divide it by time, that is your impulsive force. That is the force. Force have to using change of momentum divided by time. Megan, you are using the force, is it? Okay, Crystal, now is your time. Calculate the force. This force is mv minus mu over t. This is over the time. So try it and then tell me your answer. Teresa, is it okay? Just now the impulse question. Emily, correct, but I want you make it two significant figure. Can be 2 to 3 lah. Normally, I would just making two significant figure. Oh, Y10, this is one significant figure only. This is one significant figure only. Two significant figure, actually we will get a negative 390,000 Newton. It's supposedly, if not mistaken, according to Emily, answer 393,750 Newton. I want two to three significant figure. 1, 2. Then you ask yourself, 3 can be at 1 or not in mathematics? Cannot. So it will become negative 390,000 Newton. Correct. You need times 10 power of 5. Let me check. 1, 2, 3, 4, 5. Yeah, correct. Crystal, correct. Unit, unit. No unit, no ma. Okay, here. Is it okay until right now? So you can differentiate between impulse and force. Impulse is change of momentum or force times time. Impulsive force is the change of momentum. You have to divide it by time. It's different, okay? So at here, they're asking you how the shape can help you travel in high speed. If you can travel very fast, it's because what is reducing? How you designing this shape to reducing what? So that you can move very fast. Any of you got any idea? Why the shape like this? Actually, they want to reducing what? The front head. Their shape of front head. They want to reducing what? So that you can move faster. Emily, correct. Licious, correct. You see the shape at here, we can say this shape is streamline shape, right? Why we need to design in this way? So that it can move faster because we want to reducing air resistance. Correct, very good. To reduce air resistance. Okay. The shape so that it can travel at high speed is because we want to reduce air resistance. Okay, next question. The train will took 80 seconds to reduce the speed from 84 to 42. So it's reducing 42 meter per second, right? Now they're asking you, with the same braking force, we're applying, the train will take longer time, more than 80 seconds to reduce from 42 to 0. It's still reducing 42 meter per second. Just now also 42. But one is from high speed, another one is from slower speed. But why if in slower speed, you need to take a longer time so that you can stop? I apply the same braking force. Same. So if braking force is the same, that means that friction is the same. Braking, here it will providing the friction. Car moving forward, this is called thrust. The car moving forward is called thrust. So there is one more force at here. Just now we say this is called air resistance. Am I right? Okay, since same braking force, so it will be same frictional force, friction. But then why at lower speed, we need to take a longer time to reducing from 42 meter per second to 0. This one have to related with air resistance. Have to related with air resistance. Do you guys still remember the terminal velocity lesson? A few lessons ago, we learned about terminal velocity. When the skydiver jump out, initially no air resistance. So we will accelerate at 9.8 meter per second square. After a certain while, because we accelerate, so we start to have air resistance. So the acceleration will decrease, right? Until a certain moment, air resistance is equal to your weight. So at this moment, object moving with terminal velocity. This is one of the lessons we already learned called terminal velocity. So can you see that when you are accelerate, that means that you speed up, faster speed. What happened to your A? Your A will increases. Air resistance is increases when your speed is increases. So at here, how we relate it to our question, this question, can you see that at higher, can you see that at higher speed, it will be able to slow down at 80 seconds? It's because higher speed air resistance is higher. Higher air resistance to help to stop it. There is force called air resistance to oppose your motion. That's why you can slow down it at 80 seconds. But when you are at 42 meters per second, your speed is low. Then your air resistance also decreases. When you are walking, can you feel the air resistance? Cannot. But when you are sitting in the car, you put your hand at outside of your window, of course cannot do, it's so dangerous. But you can feel the air resistance. So at 42 meters per second, the speed already decreases. Speed decreases, air resistance decreases. Air resistance decreases, that means that the force to oppose your motion also decreases. So I will need to take more than 80 seconds to slow it down. Okay, do you able to get my idea? Okay, write down the answer. Less A resistance at slower speed. Is it okay? Here I draw just now the diagram that I draw. Initially, time is equals to 0, only weight. So it will accelerate at 9.8 meters per second square. After that, because it's accelerate what? So they will start to have air resistance. But then the weight still greater than your air resistance. So your acceleration decreases. Until a certain moment, air resistance increases until it balances to your weight. Okay, until your weight equals to your air resistance, acceleration no more. Okay, actually it's moving with terminal velocity. This is a few lessons ago we learned about this. Okay, so here I want to emphasize and how to relate to our topic right now is because I want to emphasize air resistance increases as speed increases. Accelerate meaning speed increases. Although acceleration decreases, not that fast is increase the speed. Think back the video that I show you, starting from 0, then increase 10, 20, 30, 40, 50, until 50, 51, 52, 54, 55. It's still increasing, but slow down the rate. So this is the idea we can relate back with what we learned. Is it okay for D? Megan, okay. How about others? We talk okay. Licious, Emily. Teresa, okay. Crystal, okay. Emily. Emily, okay. Okay. Then next. On a weight day, weight. What do you have to think? Weight will affecting what force? This question, I don't want to tell you, but you think. Because I already draw out the diagram for you. Okay, this diagram, there is 3 forces. Okay, here. Yes, okay, here. Okay, here. On a weekday, the train need to travel a longer distance or greater distance before it stops. Although it's still having the same speed, initial speed is the same. Then before the brake apply, but right now it's on a weekday. So you think about yourself, on a weekday, can you run? Then if you want to stop, easy or not? What affecting? Is the thrust, air resistance, or friction? Emily, very good. So actually, which one become what? Become more or become less? Hui Tong correct. How about others? Weekday. So you ask yourself, weekday actually, how was the force that you experience? Okay, which one? Weekday. So you got water, right? On the surface, between the surface of your tire and your road, okay? In between them got water. So actually your friction, it will affecting your friction. frictional force more or less? On a wet day, friction force between rails and trains, more or less on the wet day, right? Tell me. Become more or less. Crystal, let me check. More friction? More friction? We turn less friction? So which one? On a wet day, can you run? We will say, don't run. Why? Actually, friction will become less friction. Okay, sleepy, less friction. Your shoes hard to grip on the surface, so less friction. Is it okay? Can we go to your question number 7? Okay, Okay, next. Thank you. A student catch a cricket ball. The speed of the ball immediately before. So this is your U. Your mass M. So be careful. The mass given at here is in gram. If you didn't convert, that is the trick. It takes 0.1 second T. And bring it to the rest. That means that finally it will stop. V equals to 0. Can you find the force? Tell me. Any of you get the answer? Yes. What is a unit, Hui Tong? Always remember with the unit. Emily, you forget about changing gram to kg, Emily. Crystal, you forget to change gram to kg. Hui Tong, correct. Always get used to write formula before you do substitution. Okay, 160 gram is 0.16 kg. Final is 0 minus 0.16. Initial is 18 divided by the time is 0.12. So your answer, if you do it correctly, should be negative 24 Newton. But of course, if you check back the answer scheme, then most of the time they will just giving you 24 Newton. So you get a positive or negative, doesn't matter. Okay, here is actually, remember to convert. Here is the tricky part. Okay. So at here, next question. As the student catch the ball, she will move her hand backwards. What is the effect of this action on the student's hand? So imagine you are going to catch a moving object. You want the force acting on you is big or small? You want a big force experience or small force acting on your hands? Which one? What do you think? Small. Hui Tong says small. Crystal says small. Yes. Then I want you to think, if you want a small force acting on you, actually what you are trying to change, so that when you move your hand backward, actually you are changing what? At the end, you can make the force become smaller force. Crystal said time. Yes. You move your hand backward, actually you make your time longer or shorter to stop the ball. Longer the time or shorter the? Yes, Crystal, correct. So at here, boys and girls, you see, move her hand backward. After catching the ball is here. Okay, whatever lah, okay? So you slightly move backward a bit. So basically, you longer the time. Time can be longer to stop it. You not like catch it only at the very short time. You trying to catch it and then move backward, only stop it. So you are increasing the time. So at here we say that longer the time of impact, so that you can, what is the effect? So we are reducing smaller force on hand. All the things we have to think how we are protecting ourselves. Okay, smaller the force, but how longer the time of impact. Like just now, you bending your knees. Okay, bending, then you stand. That is a longer the time to stop it. Okay, is it okay, dear? Can I proceed to the question number 8? Okay, Teresa said okay. Megan, okay. Okay, this question is 2024, last year past year question. Two children balance on a seesaw. A seesaw is a length of wood which rotates about a center pivot. The concrete floor, oh my god, here is concrete. Okay, but under the seesaw is replaced by a rubber. So you have to ask yourself, what is the difference between concrete and rubber? Why I need to change it to become a rubber? A child fall from the seesaw and experience an impulse when they hit the floor. Explain how the rubber can reduce the injury. How to reduce injury? So your idea can be about impulse, force, or momentum or time. So ask yourself, reduce injury. This sentence more easier. Reduce injury. So you are trying to reducing what? Reduce injury. What you are trying to reducing? Crystal, good job. Emily, good job. Teresa, good job. You are trying to reduce injury. You are trying to reducing the impulsive force experience on you. Then again, I ask you how to reducing the impulsive force. Second point, tell me how? How? Why I change from concrete to rubber? I can reducing the impulsive force. Any of you got the idea? Yes, Crystal. When you are changing from concrete wall to the rubber wall, when you fall and hit it, actually you are increasing the time. Hit it to stop, it take a longer time. Although for us, seems like nothing different, but actually 0.0 some different, the time also a very big impact. Okay, so at here, second point at here. Okay, so at here, what is the answer we can answer here? What we can give the answer here? They can say that, we can talk about impulse. Impulse is what, dear? Impulse is change of momentum, right? Okay, change of momentum. Change of momentum, formula is mv minus mu. It doesn't involve with time. So although you're changing from concrete to the rubber, it doesn't involve with time. The final speed and initial speed actually are the same. So this one is the same for both. Impulse for both, concrete wall or rubber floor, concrete floor or rubber floor, actually is the same for both floor. Doesn't have any different. The difference is, okay, time become rubber floor. Longer time, longer time of impact when they hit the rubber floor. Okay, smaller impulsive force on child. So less injury. Impulse, no change. You using concrete wall or rubber wall? Concrete floor or rubber floor, no change for impulse because impulse is mv minus mu. Doesn't involve with any time. Okay, at the end, hit and stop is 0 watt. Initially, if falling down, the speed is the same watt. Okay, so at here, momentum change or momentum, which is the impulse, there is nothing change. Second, what is the changes? Longer time. Longer time of impact, smaller impulsive force. Is that clear? Yes or no? Yes, Teresa say yes. Okay. We talk. Okay, then we goes to page number 8. Page number 8, my dear, here. Okay, track to track. This one involved with last week what we learned about momentum. Still remember momentum formula? P equals to m times v. Change of momentum is mv minus mu. Okay, here. So boys and girls, the track A is 6,000. Move towards here 5 meter per second, approaching to the track B, 5,000 kg, which is stationary. Calculate the momentum of track A. I only want momentum of track A. Can you count for me? Track A momentum using mass times velocity. Tell me your answer. Emily, good job, Emily. $30,000 kg meter per second. Mass kg, velocity meter per second. So your answer is 30,000 kg meter per second. Is it okay? Okay, so can we try with the next question? The truck will collide, okay? Then after that, they will bounce off each other's but undamaged. After collision, the truck B have a momentum of 27,000 kg meter per second. For truck B lah, after collision, initially the truck B doesn't move. Truck B, yes, doesn't move, stationary. After collision, it start to move. So momentum is 27,000 kg meter per second. What is the impulse on the truck B? Can you tell me what is the answer? Impulse for the truck B, mv minus mu. What is the impulse? Final momentum is 27,000. Initial momentum. What is the initial momentum for truck B? What is the initial momentum for truck B? Initially, the truck B is stationary. Is there any momentum? My answer is no. There is no momentum for truck B. So at here, this one, 0. So your answer should be 27,000 kg meter per second. Is that clear, dear? Is that clear? So this question wants you to be very understand impulse is change of momentum. Change of momentum. Okay. So it goes to the next. Next one, you do it by yourself. The trucks are in contact. This is the time. They contact and then they split. Time of impact. What is the average force on the truck B? Force mv minus mu over t. Okay, do your calculation right now. Let me check. Crystal got answer. Crystal correct. Megan correct. So 27,000 divided by 0.6, your answer should be 45,000 Newton. Truck B. So truck B initial, final minus initial. Initial is 0. This one initial is 0. The yield for truck B initial is 0. So your answer should be 45,000. Next question actually is last week question. Okay, maybe I can draw again. This is truck B. This is truck A. Truck A moving 5 meter per second. So it's 6,000 kg. This is 5,000 kg. Okay, then after that, after collision, so B and A, how they move. I want to know the directions of moving. Okay, so they tell you that this one momentum for truck B. Momentum for truck B after collision is 27,000 kg meter per second. So what is your final speed for your truck A? Okay, can you try to do calculation? What is your final speed? Using the last week what we learned, momentum before equals to momentum after. So M1 U1 plus M2 U2, or I say A B B equals to MA VA plus MB VB. Initially, this one at rest, not moving. So this one actually is 0. Then equals to MA 6,000, but velocity I don't know. Plus, this one is B is, after collision is 27,000. Initial MAUA, just now we do calculation, which is 30,000. Okay, you try to digest and check your working set with my working set. Can you understand my working set? What is your answer for your speed of truck A? Do you able to get the same answer as me? My answer is 0.5 meter per second. A, this is B. I don't need to count momentum for the truck B. No need, because they already give me final of the truck B momentum, 27,000. Is it okay, dear? Okay, Megan get it. How about others? Did you able to get this answer? Crystal, okay. Actually, this is the last week topic. Principle of conservation of momentum. Okay, Hui Tong, okay, good job. Right, dear, if okay, then we go to your page number 9. Last question. We got 5 minutes. We complete it within 5 minutes. Okay, here, next. Okay, dummy of a mass to represent you lah. Okay, we cannot using use to do a test, crash test, right? Okay, we use to make sure the safety of a new car. The car approach a solid barrier at, so this is initial. It crashed and stopped suddenly, so this is your final. Stop is 0. Calculate the momentum before you collide with the wall. Can you calculate the momentum for me? Before you crash the wall, barrier. What is the momentum? Always write down formula, substitution, final answer with unit. Emily? Correct, Emily. Yes. Careless, M times V. Mass is, what is my mass? 70. What is my initial velocity? 20. 0.01400 kg meter per second. 1400 kg meter per second. Is it okay? What is the impulse that must make apply so that it can bring it to rest? What is the impulse, dear? Faster, faster, give me answer. We got another 3 minutes. What is the impulse? Any of you? This one no need to do calculation, dear. What is the impulse? No need to do calculation. Impulse is change of momentum, am I right? At the end is at rest. So, here, changes of momentum. So initially is 1400, at the end is 0. So your impulse, you just write it down only, 1400 kg meter per second. It changes from 1400 to 0. So how much changes of the momentum? Answer is 1400. That's why only 1 mark. And then there is not much space for you to do calculation. So normally the answer is very straightforward. No calculation, we also can know. Is it okay? Yes or no, dear? Okay. So can you help me to do calculation? They give you the time t. They're asking you deceleration. We don't have formula for deceleration, but we count for acceleration. V minus u over t. From the a at here at the end, then you only decide what is your deceleration. Okay, do your calculation and then tell me. Come to rest. So final is 0. Answer, answer, answer. Crystal. This is acceleration. Crystal, correct. This is acceleration. But what is deceleration? So here, come to rest 0 minus initial is 20 divided by time 0.2. Your answer, you will get negative 100 kg meter per second square. But the question said deceleration. D already bring the meanings. D already bring the meanings of negatives, bring the meanings of slow down. So at the end, we don't need to put a negative anymore. Our answer, final answer should be 100 kg meter per second square. Is it okay, dear? Can. So we proceed to the last page. Okay, let's go. Okay, they got the seat belt and then airbag to bring the dummy to rest so that it doesn't hit the windscreen. So it have the deceleration, okay, negative 800. But when we do substitution for that, we don't need to put a negative lah, okay, resultant force. So F equals to MA, am I right? Your mass is 70. Okay, this one is 80. Your answer at here is 5600 Newton. If you want to put a negative, also never mind. You just get an opposite direction only. Doesn't matter. Okay? So at here, this is the force that it will be experienced. Is it okay? It's just apply the Newton's second law. Force, mass, acceleration. Is it okay? F equals to ma. Newton's second law. Okay, how about others? Hui Tong, is it okay? Teresa, Licious, Emily? Okay, last question already. Okay, here. Deceleration of the dummy, which means that represent the real person now, okay, is less. Okay, this one value is less than the passenger compartment because we got the seatbelt, okay? So compared to the passenger compartment, the dummy, because of the seatbelt and the airbag, okay, our deceleration is less. If your deceleration is less, what is the benefit to our passenger, to us? So you ask yourself, ask yourself, what you want, how you protect yourself? Because this is talking about safety, what? How you protect yourself? You are trying to reducing what? You are trying to reducing your force, am I right? The impulsive force acting on you. So we are trying to reduce impulsive force. Then they're asking you, acceleration for the dummy is less. If your acceleration is less, your force also less. So this is the benefit, okay? So the force on passenger, the dummy is represent passenger lah, is less, okay? Less than without seatbelt or airbag. So passenger less likely to be injured. Always ask yourself safety. So we want to reduce impulsive force. Why the deceleration can be reduced? Because just now we say F equals to ma. F equals to ma. Your A reducing, your force also reducing. Okay, we're using seat belt help us to reducing the impulsive force. Is it okay? Remind you again, next week we don't have lesson. If for today's lesson no question, actually we can stop our lesson at here. But can you give me response? Is it okay for the last question? Crystal okay, Hui Tong okay. How about others? On next lesson, not next week, it's next lesson. You have to get ready with your protractor. Next lesson number 10 is we need to using protractor, protractor. Okay, Teresa, is it okay? Licious, okay? Where are you? Let me have a look. Licious, okay. So that's all for our lesson today. Thank you, class. Bye-bye.